Welcome to your Rational Functions tutorials for Chapter 9 of Algebra 2B. We're going to cover these four things in four separate videos. We're going to cover first rational functions in the form y equals ax plus b over cx plus d. This is not the HK shifting format. It's more like standard form from our quadratics unit versus vertex one, but the equivalent graphs for rational functions. So let's get started. I've got an example here that is y equals x plus 2 divided by x minus 2. Those are our two rational expressions. We have to remember that we can't intuitively just see what our constant of variation is, so we can't assume whether it's positive or negative. But we can look at a couple pieces of information. So first, horizontal asymptote comes from the two coefficients at the start here. So those two things will give us the horizontal asymptote. So it is 1 over 1 or 1. Remember, we write our asymptotes as equations. The vertical asymptote comes from the denominator because we care where the denominator is 0. So in this case, if x minus 2 equals 0, then adding 2 to both sides would give us the fact that if x equals 2, then we're dividing by 0, and that's problematic. You can't do that. So this is where the graph can never equal, and so we get a vertical asymptote. So this is our vertical asymptote right here, horizontal asymptote y equals 1. Let's go ahead and set these. I've got some lines to help us out here. Here's 1, and y equals 1 is there, and x equals 2 is here. So in a sense, we've kind of shifted our graph over 2 units and up 1 unit. Now we have to figure out what the constant of variation is. So we want to be looking for the pattern of A. And remember, when we're graphing, if we know A, let's suggest that A was 5. We'd go over 5 and up 1, or conversely, we'd go over 1 and up 5, and it's that over 1 and up however A is that really helps us. So what we're going to do is we're going to explore that. We're going to go either 1 unit to the right or 1 unit to the left of the vertical asymptote, because however far up that tells us will give us A. So we're going to use 1. So I'm going to put 1 in for x, and we're going to evaluate this. So I'm going to get 3 over negative 1 if I put 1 into the original equation, and I get negative 3. Now these are two coordinates. This is a set of points, 1, negative 3, that is off the original xy coordinate plane, not our shifting. So I'd go over 1 and down 3 right there. So what does that tell us? Okay. What that tells us is that if you look at our new or our shifted axes, we also call them our vertical and horizontal asymptotes, you'll see that from this origin I go over 1 and down 1, 2, 3, 4. Okay? So what does that tell us? That tells us that A is 4. Okay? At least in magnitude. So if it's 1, 4, then I reverse it and go over 4 and down 1, and I get a second point. Okay? So if I graph the asymptote, the graph here, it looks something like this. Okay? And in the top here, if I do 4 and 1, and 1 and 4, I get those very important points that we know how to graph from. And there's our graph. Okay? I just want to take a second before we end this video to show you that if I had chosen this other point, instead of 1, I'd chosen 3 and put that in here, I'd get x plus 3 plus 2 is 5 over 3 minus 2 is 1, or just 5. Where's that on the graph? 3, 1, 2, 3, 4. That would have given us this point. Then we would have counted 1, 2, 3, 4, and gotten A was 4 again. So either of those methods would show us that A is 4. by going 1 unit from either side of that vertical asymptote. That's key.